Hey there, we're going to go over some notes for some basic trig functions. Now, during physics, we're going to encounter a lot of different problems that involve angles. And during those problems, we're going to have to use these basic trig functions. Now, in geometry, you're going to cover a lot more functions, so we're just going to cover the ones that you're going to see in our class. So we're going to first draw a right triangle. And we'll talk about labeling the sides of the triangle. So it's a right triangle, and we know it's a right triangle because it has a 90-degree angle. And the side that is opposite this angle here, that right angle, that's known as the hypotenuse. And that side is always called the hypotenuse, the one that's opposite our right angle. The other two sides we have are what we call the opposite side and the adjacent side. And it depends on which angle we're looking at on which one's the opposite and which one's the adjacent. So let's look and see what we're talking about. Let's say we're working with this angle right here. Now, in math class, a lot of times they'll just use an x for the angle. In physics, we use that Greek symbol theta. Okay, so there's my angle theta. That's the one that I'm working with. So the side that is opposite the angle that we're working with, we would label that as the opposite side. And the side that is touching the angle, we would label that as the adjacent side. Okay, so we have opposite, adjacent, and hypotenuse. Let's draw another triangle. Again, here is my right angle. So that means that this is my hypotenuse. But this time, let's say we're working with this angle here. So here's theta. In that case, this would be my opposite side because it's opposite that angle. This would be my adjacent side because it's touching that angle there. So your opposite and adjacent, they can change depending on where my angle is that I'm working with, but the hypotenuse will always be on the opposite side of that right angle. And the three basic trig functions that we're going to use in our class are sine, so sine theta, cosine theta, and tangent theta. So those are the three trig functions that we're going to use. Your sine theta is always equal to the opposite side divided by the hypotenuse. Cosine theta is always adjacent side divided by the hypotenuse. And tangent theta is always equal to opposite over adjacent. Now, back whenever I was in my high school math class, my teacher taught me something, and it helped me remember these trig functions, and I've never forgotten it. And so they taught me a word. That word was SOHCAHTOA. SOHCAHTOA. So if you remember that word, you'll never forget the order of these trig functions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, your math teachers, they might teach it differently. That's how I was taught it when I was in high school, and it's helped me ever since then to remember the order of these trig functions. So let's look at a few problems. Let's draw a triangle. And let's say that this side is x. Okay, so I'm going to solve for that side. And let's say this hypotenuse is 20 meters. And this theta here is equal to 30 degrees. Now in your calculator, make sure that you are in degree mode, not radians. Okay, so we always want to double check your degree mode that is in degrees, not radians. And so for this problem, what we have, here's the right angle. So we know the hypotenuse, we know an angle, and we're looking for the opposite side, right? It's opposite that 30-degree angle. So we need a trig function that involves opposite and hypotenuse. If you go back up there and look, the one trig function that deals with opposite and hypotenuse is your sine function. Okay, so we're going to use that sine function. So let's write it out. Sine 30 degrees, sine theta, is equal to the opposite side, which is x, divided by the hypotenuse, which is 20 meters. Make sure you include your units here. And so now we're just going to solve for x. Okay, we're going to use those problem-solving skills that we learned previously. So we're going to multiply both sides by 20 meters. And that cancels it out on the right side. So that x is just equal to 20 meters times sine 30 degrees. Now in your calculator, you just hit sine 30, enter, and then you multiply it by 20. And you should get x is equal to 10 meters. So make sure you can type it out on your calculator and you get the same answer. If you don't get the same answer, double check that you are in degrees and not radians. So let's draw another triangle. And let's say that this hypotenuse is 10 meters. Say here is my theta. And let's say this side here is 5 meters. So this problem is a little different because we know two sides, but we don't know an angle. So let's label our sides real quick. There's the 90-degree angle. So here is my hypotenuse. And that 5-meter side is my adjacent because it's touching that angle theta. So we need a trig function that involves adjacent and hypotenuse. So looking at SOHCAHTOA up there, the one with an A and an H would be your cosine. So let's write that out. We have cosine, and I'm going to leave it theta because we don't know the angle, is equal to your adjacent side, 5 meters, divided by your hypotenuse, which is 10 meters. And if you look at it, we have meters over meters, so we can just cancel the meters out. And we can reduce that to 1/2. So cosine theta is equal to 1/2. Now we're trying to solve for the angle, so we have to do something a little different here. If you look at your calculator and you find cosine, and if you look at the little letters above it, so in other words, if you hit second cosine, there's an inverse function. So anytime we're trying to solve for the angle, we're going to use that inverse function. So on your calculator, you would hit second cosine, and it'll pull up this cosine inverse in a parentheses. And then we're going to put 1/2. And then equals. And you should end up with 60 degrees. So my angle theta is equal to 60 degrees. So again, anytime you're solving for the angle, not a side, you end up using that inverse function. Let's do another one. All right, let's say that this angle theta is equal to 50 degrees. This side here is x, and this side is 10 meters. If we label our sides, we don't know the hypotenuse and we're not looking for it. This x here is opposite my 50-degree angle, and the 10 meters is adjacent side. Okay, so you kind of get the hang of it, so it's helpful to just label those sides. So we have opposite and adjacent. So if I look at SOHCAHTOA up here, the one that has the OA would be tangent, right? So I'm going to use that tangent function. So if we write that out, we'd have tangent 50 degrees, 50 degrees is equal to opposite, which is just x, all over adjacent, which is 10 meters. and we're just going to solve for x. So we'd multiply both sides by 10 meters. So then x is just going to equal 10 meters times tangent 50 degrees. If we plug that in your calculator, you get 11.9 meters. Don't forget your unit. Let's draw another triangle. So for this one, let's say that my hypotenuse is x. So here's the hypotenuse. Let's say here's my angle theta, and it's equal to 50 degrees again. And let's say this side here is 50 meters. So if I was to label that side, it's opposite my 50-degree angle. So I'll write opposite up here. So we need a trig function that is opposite and hypotenuse. So, right, SOH, that's opposite and hypotenuse. So we're going to use that sine function. So let's write it out. Sine 50 degrees is going to equal your opposite, which is 50 meters, divided by your hypotenuse, which is x. So if you remember the video from our problem solving, whenever it's on the bottom, whatever we're solving for, the bottom of fraction, you got to make sure you be careful, okay? So we're going to multiply both sides by x to get rid of that fraction. That cancels. And that would leave me with x sine 50 degrees is equal to 50 meters. In my last step now is I would divide both sides by sine 50 degrees. That cancels here, so x is just equal to 50 meters divided by sine 50 degrees. And you should get x is equal to 6.5 meters. So we'll work one more together. Let's draw a triangle. Let's say my theta is here and it's 35 degrees. This side here is x and this side is 5 meters. So labeling my sides, I have the opposite I'm working with and the adjacent. So I need a trig function with opposite and adjacent. That's going to be my tangent function. So tangent 35 degrees is going to equal opposite, so 5 meters, divided by adjacent, which is x. So again, we're solving for the bottom of the fraction. Let's multiply both sides by x. That cancels over here. So we have x tangent 35 is equal to 5 meters. And then we're going to divide by tangent 35. That cancels here. So my x is just equal to 5 meters divided by the tangent of 35 degrees. So you're going to get x is equal to 7.14 meters. So make sure and go through and try to type these in your calculator to make sure that you're getting the right answers and that you're in your degree mode. And remember, we're just going to deal with these three basic trig functions here in our class: sine, cosine, tangent. And occasionally we'll have to use that inverse function to solve for the angle. Okay, so this here really helped me in just memorizing those trig functions. And you'll get to a point where you just know it by hand. Okay, but in the meantime, while you're learning it, make sure and you label your sides that you're working with, and it helps you identify the correct trig function.